So we're going to do this one. So I would say practice it. If you have the calculator, so we're going to do k squared. If you are using the lockdown calculator, feel free to do this one on the paper and then check and then do it there. We could do this, right? We could do this by plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just going to take a long time. Or this is one of the ones where you can use the formula because the bottom number is 1. If the bottom number wasn't 1, you couldn't do the formula. So let's say the bottom number was 3, and I had to go from 3 to 10. You'd have to plug in from 3 to 10 and add them all together at the end, okay? You might get 1. That's more than like 4 terms that you have to plug in, only 1. But the rest of them, that if you had to plug them in, they would probably be shorter, okay? I know I'm going to do it as though it's squared because that's the formula that you're actually given, which means you're probably not going to get the cubed. Yeah. All right, so the first of all, the 2 gets bumped to the front. So this would be 2 times the summation of k equals 1 to the 10, and then k squared. So then the formula for the squareds is n times n minus 1, plus 1, sorry, times 2n plus 1 over 6. N is 10 because the bottom number is 1. So then I would do 10 times 10, this should be a 1, plus 1 times 2 times 10 plus 1 over 6. So 10 times 11 times this would be 21 over 6. And then that's what I would say, try to use your calculator, right? So get used to using that scientific one. 10 times 11 times 21 divided by 6. And I'd get 385, but then you'd have to multiply by 10. Yeah, not by 10, sorry, by 2. Thank you. By 2 from the front. I grabbed the wrong thing. 2. And you get 770. Okay, let's say that it said 10 in the top. K equals 1, 2k squared plus 3. How does it change it? You can split it, right? So you can expand it or split it up, whatever you want to call that. This part is the same as this. So it would be 2 would go to the front, 10 at the top, k equals 1, k squared, plus, and then it would be k equals 1, 10, 3. So this part, we already know the answer, that's 770. And then when there's just a single number over here, we just multiply that number by n, right? So this would be 30 because n is 10. 10 times 3 is 30. So this would be 800. There will not be a lot you can use the shortcuts on. So the fallback is just take and plug in, okay? There are gonna, I think there's one that, like, I wanna say it's maybe 6 terms. So you might have one like that where you have to plug those in and then add them, yeah.
What do you do if the k is like 5?
So let's say the bottom is 5. And this is 10, and then it's the same formula. You can't use the shortcut. So you plug in 1, you plug in 5, you plug in 6, you plug in 7, you plug in 8, you plug in 9, you plug in 10, and then you add them all together. So I'd plug in 5, this would be 2 times 5 squared plus 3. I'd plug in 6, 2 times 6 squared plus 3. I'd plug in 7, 2 times 7 squared plus 3. Plug in 8, 2 times 8 squared plus 3. 2 times 9 squared plus 3. And 2 times 10 squared plus 3. And then square them, multiply it, add the 3, and then take all those numbers at the end and add them all together.
And you would only do that if there was like, so like if the k was 2, you would do 2, 3, 4, 5, 6, 7, 8.
You won't have that many terms, but yes, that's how you would do it. Yep.
The most for the one is 5.
I think there's one that might go to 6, but it's something like that. Yeah. Sorry, hang on. Go.
Oh, if the k is not 1 in the bottom, but like would it ever be that there's just like a number on the right side, like no variable? Like where you just multiply?
I mean, would there? Yeah, test question, not really. But you can multiply those. Those you can use without the shortcut.
So would you find like the n and then just multiply?
So if you're saying like if it said k equals 5, 10, and this is 3.
Yeah.
So this is 10 minus 5, which is 5 plus 1. And then you would do 3 times 6, that's 18.
Oh, okay. So you can still do that.
That's the only one you can use, yep.
So for the top one, when it's like that, you can't do the 10 minus 5 plus 1.
Correct, yep. If the one on the number on the bottom, whatever that variable is, I, K, N, whatever's on the bottom there is not 1, you can't use the shortcuts. Except for the constants. Like the constants, it doesn't matter, but
How did you get 6?
because it's the top minus the bottom plus 1. All right, so any other questions from the first slide? Obviously, we highlighted certain ones, but it doesn't mean that you can't do the extra ones if you want the extra practice. You are going to have one where it says find the certain number of terms, right? So pay attention to your instructions. If it says find the first 5 terms, you're going to have to plug in 1, then 2, then 3, then 4, then 5, and find those 5 terms, okay? And then you're going to see stuff with the factorials like 10 and 11. Obviously, 14 is the one we just went over. You don't have to find sigma notation, so you don't have to worry about anything like that. That's not highlighted. On the second page, we got into 11.2. This is where your sequence is arithmetic. So for 25 and 28, you set up the equation. And again, you want to pay attention to instructions. If it says find a n, then you're finding the formula. If it says find a n and a specific term, then you're finding the specific term. If it says find a n and s something, now you're finding the formula, a specific term, whatever, and then the sum of whatever that is. So if it says S75, that's the sum of the first 75 terms in that series. You've got to pay attention to, is it arithmetic or is it will either tell you, like these do, like if it's arithmetic, like that, or it will actually give you the first like 4 terms and you have to determine if it's arithmetic or geometric and then find the sum. So just pay attention to that stuff. How about 32, 33, 35? Any questions on those? Yeah. 32. So find the sum. Oh, this is the one that gets cut off. Find the sum of the integers from 30 to 80, right? So first of all, if it's 30, then 31, then 32, and so on and so forth, is that arithmetic or geometric? Arithmetic. So this is the sum of an arithmetic. So n over 2 first plus last. So how many terms are there from 30 to 80? This is where it gets hard. There's 51. So if I counted from 30, let's just do 30 to 35, like to see how it works, right? I would be 30, then it would be 31, then it would be 32, then it would be 33. I didn't even have to go that high, but 34 and then 35. Count how many there are. There's 6 of them because you have to count the first one, right? So there's actually 52 So 51 terms here. So then it's 51 over 2. The first one is 30. The last one is 80. Both 33 and 35 were arithmetic, so you could use that formula. I obviously wouldn't want you to have to plug in 10 terms and add them together. That takes too long. It would still work. You're just eating up time that you don't have. All right, 11.3 was your geometric. So, where? 41 is just identifying that it's geometric. 49, they give you 2 terms you're finding. And again, pay attention. When it says the nth term, that means find a sub n. And then it says then find the 10th term, so you're finding 10. And then you got to sum of finite, and then the last one was sum of infinite. Sure. So 50 gives you A3 is 6 and A4 is 1. So if I wanted to find R, because what does it want? It wants AN, and that would be A1, R to the n minus 1, and then it wants A10. So the first thing you have to do is figure out what R is. These are consecutive, so you can just take the 4, divide it by 6. If they weren't consecutive, I would do A4 on the left, A3 on the right, and then this would be R to the first. So you could do it that way, but it's going to give you the same thing because this would be, and then R is 1/6. It will not be consecutive on your test, so make sure you know how to do that. Big on the left, little, and then the difference on the R. That gives me R, so I know that part. What I still don't have is A1. So I can work backwards from either A3 or A4. I would pick the smaller one, like the closer one. So A3 would equal A1 times R to the second. A3 is 6. A1 is my unknown. 1, 6 to the second. 6 equals A1 times 1 over 36. Multiply both sides by 36. A1 is 216. Now that fills in my equation. AN equals 216 times 1/6 n to the n minus 1. That's one answer. And then A10, 216, 1 over 6 to the 9th. So I'm going to do 6 to the 9th in your calculator. That's what I would say. Definitely get comfortable with the exponents on that calculator. 216, 1 over 1,0077696. And then see if that's divisible by 216. It is 46656. 1 over 46,656. There will be not a single decimal answer on your test. It will not count. You have to keep them exact fractions.
So, one thing that's like confusing me is when do you know when to use the A1 to the times R to the n times?
It will, a lot of them will ask for it. Like it will say find the nth term or find AN. But also, if you don't know part of like let's say it says, and I put this, so I gave you an extra practice tomorrow, and I put one of these on there too, but we talked about it already. Like, if it says find S of 35, that's the sum of the first 35 terms in a sequence, right? It will tell you if it's arithmetic or geometric. But then let's say it gives you a 7 and it gives you a 70. You have to use those to figure out either R or D, right? So if it's arithmetic, I'm going to do whatever this equals over whatever, like I would do this minus this over 70 minus 7. If it's geometric, I'm going to do A70 equals A7, and this would be R to the, it would never be this big, but to the 63rd, right? And then I would solve for R. So it depends on if it's arithmetic, if you're doing whatever A70 is minus A7 over 10 over 70 minus 7. That would be to find D, and this is to find R. Then, because I don't know 35 or A1, because if it's arithmetic, it'd be N over 2 first plus last, I have to find the AN formula to find the A35.
And that formula down there, the A70 is it's basically the AN formula.
Yeah, it's just tweaked. Yep. I would say, like, get comfortable with the questions on the class kick, and then also these review questions. Like, the class kick didn't have everything, and the review doesn't have anything. I would say the marriage of those two is, like, the best review, okay? And again, tomorrow I left you, it's like 12 questions, but it's some extra some extra summation. It does not have find the first amount of terms. It doesn't have everything. It just has 12 questions, but it's a good review for some extra practice. And I posted the answers, okay? Yeah. Even or odd, yeah. No. I don't know what he's getting on the makeup, but no, on the even and the odds, there's not. I mean, on the day of, it's not multiples, it's evens or odds.
And for odd, you do the double minus 1?
Correct. Yep.
Is it even?
And the even, you just double it.
Can mine be even?
Can yours be even? Sure. Just because you asked. Mental note, Thomas Ferrier to give Tomas the easy one. Done. Okay.
Easy.
Yeah. Any other questions from that page? Right, there's one more. Okay. Questions here? Yeah.
For 57, I got 0.23056 because I put the...
So actually, this is not a great question because this would have to be a fraction. So let's redo it as though it's a fraction because you'll keep it exact. So 10, and then that would be 6/10, which is 3/5. So let's say it's that. That would be the format it would be in. You're not going to get a decimal because I don't want a decimal answer. So do that. All right, so this is, first of all, it's geometric, right? We know it because it's raised to a power. It's geometric and it's finite, which means it's a1 times 1 minus r to the n over 1 minus r. a1, if I plug in 1, is 10, and then 3/5, 1 minus 1 would be 0. That's gone, and it's just 10. Sometimes it is the number on the front, but if the bottom is not 1, it is not. So you have to make sure you check that. Then I'd get 1 minus my r is 3/5. The n here is 5 over 1 minus 3/5. Then this is where you have to be cautious using your calculator because you can't do 3/5 to the 5th. You have to do 3 to the 5th. Well, first of all, it's 10. 1 minus 3 to the 5th is 243. 5 to the 5th is 3,125. Over, you can do 5/5 here and make that 2/5. Every single time you're going to have to find a least common denominator, and that front number is always 1. So it's just the 3,125 over 3,125. Then I'm going to subtract the 243. God bless you. So 10's on the front. Top is 2,882 over 3,125 over 2/5. Then we flip it. This will always simplify. So divide that by 2. 1441, 3125 divided by 5. 625. You get 10, 1441 over 625, and then 5 goes into both of these. And then it's 2882 over 125. That would be how you keep it.